Welcome back to Samsung Foundry Silicon Universe series. I'm your host, Sylvie Kadivar, Senior Director of Marketing here at Samsung Foundry. Today, we're actually going to be starting to dive into some of the details of actually Samsung Foundry's high-performance solution offerings. And we're going to start with process technology at the core of many designs. For this, I'd like to welcome Dr. Sriram Balasubramanian, our resident process technology expert. Hi, Sriram.
Hi, Sylvie. Thanks for having me on.
How are you doing?
All right. Looking forward to this.
Well, great seeing you, and I love your background. So, Sriram, there are very few players that can innovate in the advanced technology nodes, and they continue to push scaling limits. Can you explain a little bit more how Samsung Foundry is positioned and is at the forefront of this innovation?
Sure. So Samsung is really in a unique position based on our long proven track record as a technology leader. And it's based on our ability to innovate on these advanced nodes and our ability to keep pushing the limits of scaling. And we've established technology leadership in terms of scaling transistor architectures as well as pushing lithography scaling over multiple generations. So for example, Samsung Foundry was the lead foundry to move into the FinFET era, starting with our 14 nanometer technology node. Samsung was also the industry first in EUV deployment, and we're now ramping our third generation EUV into mass production later this year. Samsung is also the clear industry leader in gate-all-around or GAA technology, which we've announced as our 3 nanometer solution. The gate-all-around architecture has significantly improved gate control, and this enables continued transistor scaling into the 3 nanometer regime and beyond. And it does that with continuous PPA improvements over FinFETs, as well as continued voltage scaling.
That's amazing. First in FinFET, first in EUV, and first in GAA. A lot of innovation and a lot of scaling and speed in order to deliver these process nodes in a timely way. Let's now take a closer look at the performance platform segment, particularly applications like HPC, AI, high-speed networking, among others. What are actually the key process development trends that are required in that space?
Right, so mobile has been the primary driver for scaling for the last many nodes, and prior to that, it used to be PCs. But given the importance of the performance segment as a whole and the rapid progression towards custom chips targeting AI-like workloads, so this is going beyond traditional CPUs, GPUs, we need to now think about the performance segment requirements as a whole upfront, and then define technology to be more holistic. So look at both mobile requirements as well as the performance segment requirements together.
So if we combine now the technology leadership and the trends, how is actually Samsung Foundry positioned to support these trends?
Right, so what that means is that at Samsung, we need to take into account both the mobile and the performance segment requirements upfront when defining these advanced process nodes. So this is clearly becoming a challenge for the industry because the scope of this definition is now wider, but it's important to lock down these requirements early on so that the performance segment requirements are captured holistically upfront and not considered an afterthought. Given HPC is not a monolithic segment, there's CPUs, GPUs, as well as NPUs. So process technology definition needs to address a wide set of requirements with varied power, performance, and density requirements. And we need to do this early on in the technology definition cycle.
So Sriram, given the varied set of requirements, what are chip designers looking when they're selecting process nodes for their designs in the high performance space?
Firstly, the technology offerings need to be optimized across the various performance applications such as CPU, GPU, NPU. So essentially what designers are looking for is a menu of offerings. For example, some of these applications use designs that are targeted towards very high performance, for example, server-like CPUs. So raw performance or Fmax becomes the critical figure of merit. But power is really critical too for many high performance designs. Designs have been power constrained for a very long time now. So aspects of the technology need to be power optimized as well as power efficiency optimized. So performance per watt like metrics become really critical. There are applications where density is also crucial. So ultra high densities and ultra high density memories become really important as well. So in all, we enable a range of offerings. So designers have the flexibility to pick the right technology option to optimize their designs to meet their PPA goals. And the key is to define these technologies by working with our customers and partners from a very early stage to ensure the technology definition meets their design requirements. So this involves extensive DTCO or design technology co-optimization, as well as STCO or system technology co-optimization early on. And this is essential to make sure that technology definition is system aware. And that is becoming even more important in the performance segment.
That's quite a lot to think about. Performance, power, density, DTCO, STCO. Now, when you look at the applications themselves, what does that mean in terms of selecting the process nodes? There's a wide variety of technologies out there. So what do you select for what?
So we offer a wide range of process nodes, FinFET technologies, EUV FinFETs, as well as GAA technologies, ranging from nodes that have the best PPA per dollar, so these tend to be the older nodes, to nodes that really push the limits on best-in-class PPAC. The 4 nanometer and the 5 nanometer FinFET nodes are a critical part of our technology portfolio targeting the performance segment. But what the industry has seen is that supply voltage scaling has really stalled with FinFETs. They've somewhat plateaued with the FinFET nodes. So at Samsung, we recognize this diminishing return from FinFET scaling early on, and we've been focusing on gate-all-around architectures for our 3 nanometer nodes and beyond. So the gate-all-around GAA MBC FET, or a multi-bridge channel FET, is our solution to transistor scaling in the 3 nanometer regime and beyond. And GAA technologies fundamentally extend device scaling because it's a better device with improved gate control, restores voltage scaling, which is really critical from a power point of view, and also offers flexible design and a friendly architecture with variable sizing. FinFET sizings were inherently quantized, but GAA now restores flexible sizing and becomes an important design norm. So overall, there isn't really a single node that would meet all of the needs of a performance segment, but Samsung does have a wide portfolio of offerings to offer these varied segments.
So it's really great to see that we've got a broad portfolio for a segment that also has a broad set of applications. Can we elaborate a little bit more about the unicity of the Samsung Foundry solutions?
Sure. So some applications use designs that are targeted towards very high performance. So for example, high performance CPUs, these often require libraries that are targeted towards high performance. So tall track libraries, optimized VT landing spots, including ULVT-like devices. There's also a need for overdrive or super overdrive voltage domains to scale to very high performance. There's also a need for a variety of RC optimized metal stacks to help with efficient power and clock routing. On-chip memories are also really critical. So from a memory enablement point of view, there are a range of high performance memories such as single port, multi-port SRAMs, high speed register files, TCAMs. All these are enabled with various kinds of power saving features. Also, from a library point of view, there's a full suite of cells in our performance optimized kits that are optimized to meet both the high performance as well as the low power requirements for our designers. Some aspects of the technology are also optimized towards power efficiency, like we talked about, so performance per watt like metrics. And there's also support for ultra-low power operations. So designers can take advantage of features such as dynamic voltage and frequency scaling, or DVFS. And so to enable features like DVFS, it's really important to do low voltage accurate characterization of performance and power to ensure that designers can now swing between a high performance mode or a low power mode seamlessly. In addition, we also offer ultra high density libraries as well as ultra high density memories. And this is really to ensure designers have the right solution for their density requirements as well as power requirements. And to do all this, Samsung collaborates with our customers in a very early stage with very detailed DTCO early on in our technology definition. This targets libraries, memories, metal stacks, and many more things in our technology portfolio.
That's pretty impressive. So in addition to just having a broad variety of process nodes, in addition to looking at the process nodes in the application more closely, you mentioned that Samsung Foundry actually offers also a wide performance of optimized libraries, memories, and metal stack options, but also a completely new way of looking at things through the ever-increasing focus on DTCO and SCCO from the perspective of optimizing these platforms. Are there any other considerations that chip designers have to take into account today for optimizing and designing in the performance platform space?
So there isn't really a single node that would meet all of the performance segment needs, but Samsung has a wide portfolio of offerings to address the varied customer requirements. Equally important for performance customers is the early availability of all the key IPs, including the high-speed interfaces, as well as D2D solutions. There's also a clear industry direction towards heterogeneous integration. So multiple dies potentially fabricated on different technology nodes, all integrated in a variety of 2.5D and 3D solutions. Samsung recognizes this clear industry direction, and we've worked very closely with our customers and partners to enable a full range of silicon technologies, high-speed IPs, as well as packaging solutions that in turn enables our customers to focus on system-level innovation now.
Thank you, Sriram. You've given a lot to think about. Not only is process from an innovation standpoint, there's the whole development happening there, but also all the interconnects between the process development as well as the libraries and the collaboration with the customers. And the fact that you really can't decouple process with IP development and packaging development. So thank you so much for bringing this all together and shedding more light about Samsung Foundry's readiness in terms of providing a more complete solution. And this is actually a great segue for the next series that we're going to be providing to our customers around IP and packaging. So thank you again. And I very much look forward to seeing you again, Sriram, to talk in more detail about our future developments. Thank you.
Thank you, Sylvie.